Hello friends, and welcome to a lecture on optimization. Today we will learn how to use PuLP for solving a linear programming problem. PuLP is a very popular linear programming solver. To install it in Python, all you have to do is pip install PuLP in the IDE of your choice. The IDE that I prefer is Spider. So all I do here is do pip install PuLP. Now it gives me requirement already satisfied. The reason is I have already installed it. Now let's go to the problem that we need to solve. That's on your screen now. The window glass problem. I have discussed the formulation of this problem in one of my previous videos. The link to this video will be found down below and also on your top right. Now we have to maximize the function z is equal to 3x1 plus 5x2. Subject to the constraints x1 less than equal to 4, 2x2 less than equal to 12, 3x1 plus 2x2 less than equal to 18, and x1 and x2 both should be greater than 0. To solve this problem, I have already created a template file. The reason being, you can easily follow what I am doing. You can use this template file to solve other problems. So let's go ahead and load the template file. Once you have the template file, don't start using it immediately. Save it. So file, save as, and let's give a template name 4. Now this will give you an advantage that if you make any mistakes, you can always go back to the original template file, once again copy it and start afresh. Now let's come to the template file and start solving our problem. So first, we have to define our model. So for this, we have to write model, LP model, and we have to write the model name. So I'm going to write it as window glass. That's the model name. And we have to maximize in this problem. So we write LP maximize. That's it. Oh, so there should be a comma here. That's right. Okay. Next, we have to define our variables. It's a 2-variable problem. The 2 variables are x1 and x2. So if we remove the hashes from here, and the lower bounds of these variables are 0. So we write low bound is equal to 0 for x1, and similarly we copy it down for x2. Now we have to define our objective function. Now as you can see here, to the model, the objective function is being added. We have defined the model here. Oops. We have defined the model here. And now after this, okay, there's an extra bit of comma here. Let's remove it. And then we have to add to the model the equations. So let's start with adding our objective function. Our objective function is 3x1 plus 5 x2, and if there is any constant, you have to add it as plus 12 or plus 30 or minus 35 or whatever it is, but there will be no equal to sign after this. Now to our model, we have to add our constraints. Have a look at how do we add constraints. So our first constraint is x1 less than equal to 4. Now just see here, after x1 less than equal to 4 is written and the value of the constraint also is written. That is, the limit of the constraint is written. The difference between the objective function and the constraint is the objective function doesn't have an equal to sign at its rightmost end, but the constraint has the constraint inequalities and equalities at the rightmost end with the value of the inequality. So let's get ahead and define the other constraints. So the second constraint is 2x2 less than equal to 12. And the third constraint is 3x1 plus 2x2 less than equal to 80. We are done. So we have added the objective function and the constraints to the model. Once we have done that, we are ready to solve the model. So let's go to this model solve, remove the hash here so that it can be executed and run it. We have successfully run it. To see the output, all you have to do is copy these print commands, go to edit, go to comment, uncomment, and uncomment it. Now these commands will run. Remember, these print statements that I have put in the template can be very much be used for any problem that you're solving. So let's run it. And there we are. It says printing of the result starts. The model has optimal values. So it has solved for the optimal values. And the value of the variables are x1 is equal to 2 and x2 is equal to 6. And the value of the objective function is 36. Well, the first constraint, that is x1 less than equal to 4, has a slack of 2. Now, what does that mean? It means that x1 is equal to 4 minus 2, that is 2. For the second constraint, the slack is 0. And for the third constraint also, the slack is 0, which means after solution, the constraints have come to 2x2 equal to 12 and 3x1 plus 2x2 equal to 80. The constraints have been met. So that was all about how do we use PuLP to solve a linear programming problem. Wasn't it simple? Well, you can solve bigger problems. Remember, linear programming wouldn't have come into the fore of applying it in industry had it not been computers. It is easy to solve a linear programming problem using calculator and pen and paper if it's a 2 variable and a 2 or 3 constraint problem. The moment the number of constraints increase and the number of variables increase, it is impossible to solve it using calculator. Computers come to our rescue. Therefore, it's a good idea to learn how computers are used to solve linear programming problems. In industry, linear programming problems have 100 to 10,000 variables. It is impossible to solve it without a computer. How to solve it in Excel has been given in one of my previous lectures. That is available in a link down below. And this was using Python. It is especially for those who are comfortable using Python. So that was all about it, friends. If you like the video, share it, press like and subscribe. And do let me know if you would like to have more such videos and if you have bigger problems to be tackled. Goodbye, friends. Have a great day. Have a great time.